Hello and welcome back to the lecture series of querying with the T-SQL. And the previous videos, we have used, sorting and filtering using the SQL queries as well as combining multiple tables and joins. In this one, we will be covering how to write subqueries. And in this one, we will be learning how to use subqueries to combine multiple select statement and also compose nested SQL queries. Sometimes when you use T-SQL to retrieve data from the database, it can be easier to simplify complex queries by breaking them down into multiple simpler queries that can be combined to achieve the desired result. And T-SQL supports the creation of subqueries in which an inner query runs and returns a value, and that value is being fed into the outer query. So we will be learning in this video about subqueries, as well as how we can use multi-valued subqueries as well as the correlated subqueries. So a subquery is a query that is nested within another query. The subquery is often referred to as inner query, and the query when within which it is nested is referred to as outer query. So we've got a outer query. Within that, there will be some clauses that will be used to have uh, an inner query, which can be executed as a separate query as well. We will show it. I will show you in the practical example of. This AdventureWorks database. So if you're following along, we are using AdventureWorks database in Azure Data Studio, and you can look for to download and install Azure Data Studio from Microsoft website and fetch up the AdventureWorks database as well. If you're using SQL Server Management Studio, then that's fine. You can just connect the AdventureWorks database there as well. So I've started off with the new query. So what we'll do is I will just check a query which we were doing previously as well. So we select we'll just fetch up some order details. So basically go to the schema sales sorry just sales.lt and then sales order details. So if I execute this, so it's giving me sales order details, quantity, product ID, unit price. So I just need to if I use a max function on unit price. So this means that which is the most important maximum most expensive product in get. So we can get a maximum value of $1,466 in terms of the unit price. So now if you want to fetch any information, um, and we want to get information about a product list price which is maximum, which is greater than the maximum of the unit price, what we will do is we will embed this query into another query. So let me create an outer query first. So in order to create an outer query, let's say product list price. So I'll use selects all from name, sales lt dot product, and I'm executing this. So this gives me a product detail about it, but we need only name and list price. There you go. So now we are using the product name and list price. So we need to find out the product where the maximum the highest unit price, the list price is greater than the highest unit price. So this is max unit price in the order detail, and this is the list price of the product. So now what we can do is we can use a where clause, and we can say that where list price is greater than, either we can do 1466, but we need it to be dynamic. So what we'll do is we'll open up a parenthesis and then copy paste this value. So copy paste this query in that where clause. Now if we execute this query, so we will have all the list price which is greater than 1466. If we can run, as I mentioned, we can run this inner query separately to fetch the information. So this gives us a flexibility of saying that We can create an inner query first and then input the results into the outer query later on. Now consider another case. We want to fetch information, we want to fetch all the products from the order detail table where the order quantity is greater than 20 or greater than equal to 20. So we'll type up a query of, let's do it here. I'm just copying this, and instead of max unit price, I'm using the raw tables, product ID. If I execute this, it is giving me product IDs. But if I use distinct product ID, it will give me all the details of our distinct product IDs related to that. And I'm using where order quantity greater than equal to 20. If I execute this, so these are the two products where the order quantity is greater than equal to 20. But we want to modify this query and use a subquery that finds the name of the product that have been ordered in the quantity. So in order to fetch that, what we can do is we can use this product query. So where name from product include so this is all the name of the product. I'm using it step by step. So name of the product, these are all the names of the product, where product ID, and now we'll use the in keyword and then open close parenthesis, and now we will use the subqueries. Now we'll use this subquery. So this means it is fetching the product ID, and the reason why we used in is there can be multiple records associated with. We cannot use, I mean, I'll show you why the reason of being why we used in, but let's execute this first. So this is product, these are the products name where the order quantity is greater than equal to 20. If I use product ID equals, let's see what happens. It gives us subquery return more than one value. This is not permitted when the subquery follows this sign. So that is the reason why we've used in. And remember, in the previous videos, the in keyword has provides a comma separated values, inputs the comma separated values. So this is the product name. We can include list price as well here. So everything works from that where clause. So where product ID, and then we are using product ID with multiple tables, with different tables, and this will give the product name, the product details, which are based on the sales orders. So this is done through a simple subquery, and as per our previous video, we can use that. We can use product. We can achieve similar results through joins as well. So, for example, we will use select distinct name from sales dot product and p join sales order details as o on p dot product id equals o dot product id, where o dot order quantity greater than equal to 12. And what I'll do is I'll run both the queries simultaneously, so it will have open the results in two windows. So see this, it is displaying the same product names. We have achieved similar results, and I'll just add less price to it as well to make it more consistent. So we are receiving similar results either to use inner join or the nested subqueries as well. So this is the reason of using subquery is, this approach can be easily interpreted by the developer looking at the code than a complex join, because the operation can be broken down into discrete components, and in most cases the performance uh, of equivalent joining or subquery operation is similar, but in some cases where existing checks needs to be performed, the joins of course performs better. But subquery is an easier way to debug a code as well as establish uh, make it a more flexible related code. So now, so we've till this time we've used simple queries that are a self-contained subquery, which in which inner query is independent of outer query. So it is not dependent. So now we will work on correlated subqueries. The correlated subqueries, in some cases, you might need to use an inner subquery that references a value in the outer query. So the inner query runs once for each record return in the outer query, in which the correlated subqueries are sometimes a repeating subquery. So basically, correlated subqueries cannot be executed separately from the outer query, and correlated subqueries runs multiple times. So any value that is fetched from the subquery is fed into the outer query, and then that query executes, and again it comes to the inner query, and so on. So we'll explore some options while going through the SQL code, and then we can understand what is going on, and what difference it is, in terms of fetching the result using correlated subqueries. So let's fetch some order details from the table. So what we'll do is we'll write a query, of course, select star from SalesLT dot sales order details, and after executing this as a step-by-step approach, we are giving it an alias and also giving OD order by product ID. Oh, sorry, OD dot product ID, and we are getting the products OD dot sales order ID, comma OD dot product ID, and OD dot order quantity. So let's execute this. So once we execute this, this will give order ID, product ID, and the quantity of that particular order details. And now we want to embed a subquery in the where clause that retrieve the maximum purchase quantity for each product retrieved by the outer query. So this means that the inner query is reference a table alias that is declared in an outer query. So this means, for example, now we'll use a where clause where od dot order quantity equals, and now we'll open up the parenthesis. So it says select max order quantity. So remember, we are checking the maximum purchase quantity for each product. Max quantity from sales order detail, and this time I'm giving it name as D, where od dot product ID equals D dot product ID. So it's connecting this table, which is a similar table to this, but it's treating it as a separate entity and matching product ID of both of the table. But in this subquery, it is fetching the maximum order quantity, which is ordered by the product ID. So if we execute this, so it is fetching the fact that maximum purchase quantity for each product. And this eventually is containing a product order record for which the quantity order is the maximum order of the product. Okay, so this is going displaying a maximum order quantity, but if I try to execute the inner query, it gives that multi-part identifier OD product ID could not be bound. So this means that its outer query is bounding with the inner query, and that is the reason why we need to run these two queries as a single query. Let's take another example. So now this time what we will do is we will retrieve the company name for each customer using the correlated subqueries, and the query or the end result will return order ID, order date, and customer ID for each order that has been placed, and we will be using correlated subqueries for fetching up the customer name. We'll start off with sales order header table. Select static from dot sales order header. So this is the details about all the order. But there is a customer ID where you need to fetch the company name associated with that. So we'll just format this as, so this is order table and order by o dot sales order ID. And now we'll add a subquery without using a where clause. So this will have a, so o dot sales order ID from the table, o dot order date from that, and we can use customer ID, and we can use join as well, of course, to fetch the customer ID to details. But what we need to do is we want to directly use the customer company name. So what we can use, we can use a subquery that is called select company name from sales customers, and we will give this name as C, where C dot customer ID equals O dot customer ID. And we will give this as a column alias of company name. Let's try to execute this, and it will give an error. But now if I execute this whole sentence or a whole query, it is giving me the company name as a column. So this subquery runs and fetches up the a company name from the sales order and consider it as a column. And this is, of course, these two are must be interrelated, because this is connecting using the where clause. So we can either get a where clause within that uh, you know outer query, or we can fetch it as a and display it as a column. Now we'll solve some life examples using the product table and the sales order table. So first of it is that if we want to retrieve all the products with a list price of 100 or more that have been sold for less than 100. So let's try to find out something. If I use select product ID from sales dot sales order detail, where unit price is less than 100. Let's execute this. So we are fetching all the product ID where the list price, or sorry, where the unit price is less than 100. So this is a subquery. But if you want product select from SalesLT dot product, and the column names are product ID, name, and list price. So this is the product, but we want to apply some conditions that says where product ID in, and this is the subquery that we execute. This is unit price is less than 100, but another condition that says that have been sold for the list price of greater than equal to 100. So unit price is less than 100, but list price. So this means that we have used an where clause in the subquery, but we are using a where clause from the outer query as well. List price is greater than equal to 100. Let's execute this. So these are the product where the product unit price is less than 100. Let's to make it equal to here as well. And the list price is greater than equal to 100. So this is a bit complex, but if we break this step, if we break the query to a multiple, step by step, build the inner query first and then feed up to the outer query, then it will be easier for us to go through stuff like this. Another example, so this one is for, I'm just writing it here, product with a list price of 100 or more that have been sold for less than 100. Now another example, we will use cost. We will use cost and let's say list price and average selling price of each product. So list price we can get, selling price we can get, uh, but average we can get from the sales order detail table, average selling price. So let's start out with select all from SalesLT.Product, which is at SP, and order by P.Product ID, and let's see how it goes. It's returning all the product details, but we need to narrow our result query with P.Product ID, P.name, P.standard cost, and P.list price. This is name, standard cost, list price, and now you need to fetch. So we'll just give a space, and now what I need to fetch is the average selling price as well of that product. So in the parenthesis, what I will do is I will use select, sorry, and I will use just raw tables. For example, we'll start off with select all from SalesLT.SalesOrderDetails, and this is O. And if I execute this part of the query, it is giving me all the details with the product ID in it, and I need to fetch O.UnitPrice, where O.ProductID equals P.ProductID, and let's fetch this information. We cannot do so because we need to, this is interrelated, so we need to do it there and then. Subquery return more than one value. This is not permitted in the column. So we need to use some aggregation, and this was the requirement of using average unit price rather than the individual unit price. So I'm using average unit price here, and we'll give a name as well here as average selling selling price. So now we'll see how it goes. So against each product, it is giving me standard cost, the list price, and average selling price. You see there are some null values. This means that it's not, the product is not sold anywhere. So that is the thing that is giving me the product ID and the average selling price as well. I will copy this query and paste it at the bottom. This time, what I need to include is I need to see products that have an average selling price lower than the cost. So it's the same one: product ID, product name, product standard cost, and list price. I will need to change the query and add a where clause to it. So it says where standard cost is greater than. Now we've got another subquery, and this subquery is same as this one. And let's see how it goes. Sorry, I'm just copying many things here, but let's search and add and run here. So this query, it's using the average selling price as well, but it has a where clause as well that says the standard cost is greater than the average selling price. So this means that we are selling it in a negative. So this logo cap costed 6.9, but we are selling for 5.3, which means that there are some values which are lesser in terms of the selling quantity. And similar goes with all the other products as well, that are the standard cost is this, the average selling price is lesser than the actual ones. Lastly, what we'll be doing is we will be working with a keyword or a predicate that is called exist. And the exist predicate determines whether any rows meeting a specific conditions exist. But rather than returning them, it returns a true or a false. This technique is useful for validating data without incurring the overhead of retrieving and processing the results. So this means, for example, we use the outer query using the exist predicate, and then it returns a true or false related to the exist predicate. So let's say we'll start off. I'm just giving comment. So we'll say select customer ID. I'll use the from keyword first so that it specifies and it is helping me identify the naming the column details. So I'm using customer ID from the customer table and company name, as well as email address from the customer, and I'm just giving it a name. So I'm executing this, sorry, completely executing this as customer with the company name and stuff. And I'm adding a where clause that has a subquery, and that subquery is select count all from sales dot sales order header. So it's counting the sales. So this is counting company name which has a customer, which has a returning an order. So this where clause, I haven't specified any column, so this order count is greater than 0. If I'm executing this, these are the customer that says that has some orders, that have placed some orders. If we used equal sign, these are the customer that haven't placed any orders. This goes a similar way to use exist, and I've copied the outer query here, and then I'll used I'll use the exists command where exist, and then I'll use, instead of the aggregation, I will just use select all. So these are the ones. So this means that, in the first example, the subquery must count every occurrence of each customer ID and compare the count result to zero, simply to indicate that a customer has placed order. But in the second query, the exist return true for a customer ID as soon as a relevant order has been found. A complete accounting for each occurrence is unnecessary. I mean, it is not calculating and going through all the phase, or all the columns, or all the records associated. So this means that, existing is, using the exist one is just finding out true or false. If only first record, it will find out, it will return true. So this means that, it will, um, uh, you know it will save some space and save some processing time as well. And from the perspective of logical processing, the two queries form are equivalent. From a performance perspective, the database engine may treat the queries differently as it optimizes them for execution. And one thing more, if you're using exist one, make sure not to use any aggregation, because in aggregation, it will return a row. So your result will not be equal. It will always return true in the sense. So it's better to use, select all or select static, and to fetch up all the information. We can always use not exist command as well in that. So not exist command means this is the one which is not existing, the things which return false in the sense in the line. So this is it from this using of subqueries. So in this video, we have covered the understanding of the subqueries, using scalar and multivariate subqueries as well, using the in clause as well as the equal clause, and also use the self-contained or correlated subqueries that connect with the outer table with the conditions to manage all the aspect. If you're watching me for the first time, please don't hesitate to subscribe and like. Also, I would appreciate if you'll provide your feedback so that I can improve. Thank you so much.